Welcome to our introductory installment of Certitude Digital's video training series for all things cybersecurity and identity related. Hello, my name is Scott Deaver, and I'm the Chief Technical Officer for Certitude Digital. I also happen to be the inventor of all of Certitude Digital's patented and patent-pending cybersecurity and identity validation technologies. As I'm speaking now, it is Tuesday, August 25th, 2020, and do keep that time frame in mind as time marches on and you are viewing this video at some point in the future. At this moment, we have nearly 50 innovations patented, pending patents, or waiting for patent applications, not to mention our trade secrets, and more are arriving daily. We have nearly 1 million lines of production quality tested source code in secure repositories that comprise the libraries we provide our strategic partners so that they can integrate our solutions into their own products and services. You might think all these things are great for us, and in a different time where quality, integrity, and honesty mattered, they would be. But actually, as things stand today, it's a real problem. I'm going to go on a bit of a rant here, but not to worry. I'll straighten up soon enough and fly right so we can get back on task. But here's the deal. Nobody, and I do mean nobody, except our team had any clue how to solve any of these cybersecurity problems before we came along. In the 12 years we have been working in stealth mode, getting our patents and proving our solutions, the cybersecurity industry has grown into a behemoth, taking $180 billion out of the pockets of consumers, corporations, and the government, all without putting the slightest dent in a massive problem that steals $6 trillion from the worldwide economy every year. For reference, you should know that is 1.5 times the United States government's entire annual budget. Think about that. So the first issue is that you have this enormous problem no one else has been able to solve. But you also have 40 years of con artists and thieves. I'm not talking about the hackers now. I'm talking about IBM, Symantec, FireEye, and some real characters like John McAfee, Bill Gates, and Mark Zuckerberg, raping you out of your very shorts data-wise. In the process, they have pounded a whole lot of sand up everyone's butts about what cybersecurity is and is not, in part to hide their own thefts of your property, in part to protect their own interests above yours, and in part because they really have no clue about anything other than grubbing money. So the second problem is that there is a whole lot of self-serving disinformation out there working as smoke and mirrors to keep people paying $29.95 every 6 months on a subscription plan for products that do not work and cannot work. When those products fail, the bet is that you will blame your hackers or yourself, or in the worst case scenario, dump one vendor for another vendor's equally ineffective software in accordance with the way you've been indoctrinated. The third problem stems from the fact that during my 35 years in the industry, serving 75 major corporations and government entities in mission-critical projects, including NASA, oilfield, aeronautics, and medicine, I learned that the answers to all cybersecurity problems, though relatively simple in concept, are embedded in a completely different information set than what is presented to the public. And so that leaves us with 3 huge piles of things to learn and, in some cases, unlearn. Number 1. We need to understand the true nature of the actual underlying problems. Number 2, we need to understand past deceptions about the various problem domains and the failed quote-unquote solutions the industry has put out. And we need to understand what the underlying goals for those products were, given obviously they didn't do anything to solve the problem. This will help us identify these things for what they are, help everyone understand the right questions to ask, and clear away the noise and confusion when implementing a different solution that will actually work. Finally, number 3, we need to understand the true solutions to individual cybersecurity and identity challenges in the digital realm, and understand at a basic level how they work and why. So as you can see, a lot of information needs to change hands in order for the world to benefit from what we know. This knowledge exchange has proven to be a far bigger problem for us than any of the many technical hurdles we have overcome. In the aggregate, it is simply too overwhelming for most people at first exposure, and they tend to shut down and walk away. And yet we know 2 things. At their core, all of these problems and all their solutions are actually incredibly simple. And we know that even non-technical people are very smart, and if it is broken down for them, they can easily grasp these core truths. It is no different than with the computers we're using to have this discussion. Most people do not fully comprehend all of the inner workings of their device, nor would they want to. But they can certainly understand the basic workings of a transistor once it's properly explained, and most can extrapolate that forward to understanding how the capabilities of a transistor multiplied 1 billion or so times over could be useful in solving certain common problems. From that point on, it is simply a matter of learning how to use the various tools other people have built to take advantage of the powers of a transistor. And that is what we want to achieve here. We want to all break these things down individually into their simplest elements, and then selectively put together sets of some of the new understandings to address certain problems you would recognize and are interested in. To that end, we cannot know all the specific interests of individual members of our audience, and that audience becomes eventually quite vast because our technologies truly can solve every cybersecurity and identity problem out there, just like transistors can solve every computing problem. We want to take everyone along down to the depth of their own specific comfort level as we drill into the basic elements of these things, and then branch back out into different trails targeting specific tasks as we meaningfully apply the elemental knowledge we've gleaned to the things that interest a viewer. Each member of the audience can follow as many or as few of these threads as they wish to satisfy their own curiosity and interests. The idea of breaking these three mountains of information into tiny pieces and then building understanding from putting them back together might seem daunting, but we are innovators and daunting is what we do. We've partnered up with some of our friends at Daylox Labs, our publishing subsidiary, and came up with a plan we think will work. Chris Daughtry, a senior editor, technical writer, and investigative reporter, has helped us put together a series of questions to guide us down the paths we want to go. The questions have been prepared in advance to follow a comprehensive outline and are devised so that each can presumably be answered by me in under 3 minutes, preferably even shorter. Chris will ask each question in turn in a video session, and I will devote my answer to each question as a standalone response. If a question is going to require more than 3 minutes, I will answer the portion that I have time for and ask Chris to present me a follow-up question later. When necessary, we will edit graphics, external video, or audio into the video post-interview to help further explain the topic. The questions and their responses will be gathered into sets of 3 question and answer pairings for each video, and each video saved separately with unique enumerations and titles. Once we have published several of these separate videos, we will publish the outlines of the questions and the questions text organized by subject matter as a web document at the CertitudeDigital.com website with links to the specific video containing each answer to each topic question. Members of the audience can then traverse the outline questions at will to pursue the subject matter they are most interested in, following the course that makes them most sense to them and their learning style. We will also publish text transcripts for each video. The idea here is to build something like a directed, hyper-organized, frequently asked questions, or FAQ, section on steroids, which in its totality will eventually expose everything we know about cybersecurity and identity authentication, which you will find to be quite considerable. Because of the lengthy introduction, this first installment will be quite a bit larger than those following. With that apology, we'll ask Chris to present me the first question.
I was surprised to read that even though Certitude is a startup, you and your team have been working on this a long time using your own money. I understand you've even had several patents issued already. Is that right?
Thanks, Chris, and that is correct. To date, we have 6 issued patents. The most recent one received June 9, 2020. We have 4 more applications that are filed and are pending, 3 utility applications and 1 provisional application. We just completed an office action on the next patent that we expect to issue the end of this year or beginning of next. We have another 40 patent applications we'll be filing as soon as we have the funds to do so, but which are awaiting our WeFunder outreach and outside fundraising efforts. As of today, I have a little over $500,000 of my own money in the company as cash expenditures for development help, equipment, and patent fees and expenses over the years. And my patent attorney has another $140,000 invested primarily in unreimbursed services. Scott Orman, our longtime COO, has another $250,000 invested, mostly in the form of uncompensated expenses and services rendered. The Amulet portion of the project, which forms the basis of the cybersecurity technologies, has been in development full-time for 12 years, along with our Kirchhoff's complement encryption, which provides much of our multivariant keyless enciphering. The GNOME's technologies that are the underpinnings of our identity authentication and verification components have been in development for 4 years. The quantum technologies that allow extension of our Amulet protections into database cells and other cool places has been around 3 years. Hackless Harbor, which creates an ironclad safe workspace vault-like an embedded appliance or dongle, but as pure software is less than a year old.
I see you've got several patents pending as well, and I'm told you have other innovations waiting to patent which you have funding. I know you're prohibited from saying too much, but can you give us some hints of what is coming?
Some of this stuff is truly earth-shattering. One of our technologies I referred to previously, Ambient Quantum, allows a user to literally be on 1 million devices at once, harmless to the visited device, but also secure for the user, looking over just his or her protected digital assets as though they were being used on his or her own device in real time. Exactly as in quantum physics, where state in one place is acted on in another. This means something like your social security number can reside enciphered in a cell of a database you don't even know exists. But that social security number can only be deciphered by the entity meeting your criteria under your dynamic control without any intervention or input from the database administrator. In other words, a table in a database could have 300 million rows each, with a column having a different social security number, or for that matter, any sensitive data in any form, and every one of those social security numbers would be under the unique and sole control of the individual person owning it. Hackless Harbor has even more exciting capabilities. Think of it as a deep diving suit that wraps an inviolable protective environment around a chunk of work being performed on a device, pushing out the results under timed release to an authorized consumer on the device. We also have proxy technologies that allow one device to securely provide security services for another device that lacks memory, processing power, or storage to protect itself, a godsend for Internet of Things, IoT, devices. We also have complete closed system members-only technologies that provide hermetically sealed security for a Facebook-type environment, including asynchronous message and package delivery, storage, pickup, and broadcast or publishing, with absolute dynamic control to the users, who are the real content providers. Like so many things, once you solve the basic issues, the world opens up like an oyster.
Your claim is that none of the thousands of cybersecurity technologies out there work. Can you elaborate on that? And then I have a follow-up question.
I'm not so sure as our claim. It is more all the headlines for everyone else screaming that it's true. Years ago, there was a point in the late 80s where computers' hardware was still under power and slow by today's standards. Yet Moore's Law was still in effect, where computer speed and storage were doubling every 18 months. The increasing horsepower could have been applied to fixing some criminally stupid basic mistakes IBM made in the design of the PC and in their computer file systems. Had they done that, they could have implemented something very close to our solutions, then at the hardware level, and none of the problems we have today would exist. But no, instead the mercenary bastards wanted to drive sales and give the impression of false performance to the consumer. Their underhanded cheat was remaining reliant on these badly broken subsystems, which still exist today. To give you an idea how downright silly these baked-in mistakes were, can you imagine today buying a car to which there was no ignition, door, or trunk key, or security of any kind other than some stickers that said, "Don't steal me"? Can you imagine anything of value you might own to which some kind of security isn't attached, or to which security couldn't be added as an integral component? Of course not. But data transfer and storage, which to a business can be far more valuable than any car, has no such security provisions. In 1953, when the spinning platter hard drive was invented, the engineers read from the disk the data in exactly the same way the data was written to it, with no regard whatsoever for whose data it was, or whether the person or entity reading it was the same as the person who wrote it, or whether the person who wrote it had given permission to that specific reader. My 5-year-old was smarter than that. When she wrote something in her diary, she locked it with a key. But not IBM. Other than band-aiding on external crap that can be easily gotten around, disk hierarchy read-write bits, for example, there's nothing intrinsic or native to the hardware of a disk drive that ever asks these questions at each and every read. Each and every because, hey, things change. It all has to be artificially simulated externally, which is itself subject to external manipulation. I hope you'll ask me this question in more detail later and I can get into it in more depth. By the way, the acronym that describes the garbage IBM wraps around its files as so-called protection is actually CRAP, C-R-A-P, which stands for Collection-Related Asset Protection, or sometimes Container-Related Asset Protection. But on top of the terrible hardware infrastructure issues, you had the fact that the so-called pioneers of cybersecurity, the virus scanners, were mercenary con artists. Typically of these was John McAfee, who could best be described as a bath salts-addled murdering drifter, where murdering refers to both dogs and people. McAfee, along with several of cohorts at the time, came up with the business model that drives cybersecurity today. That model says, let the hackers stay one step ahead. Use them as the thugs in a protection scheme, where they constantly generate new threats, and we can charge users exorbitant sums to protect them belatedly, after the fact from only the most recent threat. But never kill our cash cow by inhibiting anything new that hackers might come up with in the near future. It's that extortion scheme right out of Al Capone's protection rackets in those old Chicago neighborhoods of the 30s, but writ large in digital form, that drives all of cybersecurity and identity protection schemes in existence today. When you see how fundamentally simple the solution to the true problem is, only then do you realize the true extent of the con. And if you are still at all like me, a wave of pure rage washes over you. Now, there are a few so-called cybersecurity vendors whose mercenary greed is a little less criminal in that they do not directly invoke a protection racket per se. Instead, their shtick is that they gather ever bigger piles of other people's data together. Hey, no skin off our nose if something bad happens. And throws a weak and tattered quilt of flaky security over it, hoping all the hackers won't see the big pile, or that when they are hacked, they can blame someone else, which usually winds up as claimed poor implementation by their own user. Same jerks, different game, made fatal by the entry of well-heeled, state-sponsored hackers into the game who rampage through these schemes at will. Certitude Digital aims at solve both problems, of course, by making the individual files the viruses must modify impenetrable in the case of virus attacks, and by making sure that any files the hackers steal from those big piles are all individually, uniquely decipherable by their separate owners, rendering those files useless to the hackers.